All right, so here's what I want us to do really quickly. Let's look at this graph that we have here in your notes so you can see what's going on. So this red, it's not red on yours, but if you can take your red pen and trace it, this is the distribution for when the null is true. Because notice the p sub 0 is 0.80. That's the distribution for when the null is true. This one over here, this is going to be the distribution for when a very specific alternate is true. Now, let's go back to the beginning. And in this case, that p is equal to 0.66. And I will say this, here's something that's really important. For power, okay, to calculate power, there must be a specific value for the alternative. So we picked 66%. Okay, so let's think back through what the test actually looks like. So we're assuming that Ms. Gallus is an 80% free throw shooter. In order to reject this, we need her to get a p-hat that's pretty low, right? It needs to be quite a bit below 80% for us to say, yeah, we're going to reject this, all right? So let's say we're over here in the red distribution, and we're assuming she's 80%. So if we get a p-hat that's like over here anywhere, that's real low, we're going to reject. In fact, we are going to reject anything that has a p-value less than 5%. And the cutoff for that is right here. All right? So this is a p-value of less than 0.05. So that right there, that shaded area, that's our type 1 error. If we get something that's in here, we're going to reject. And there's a possibility it can be in here and the red is still true, but it's only going to happen 5% of the time. So in this particular case, that's a value of 0.707. So if Ms. Gallus shoots anything below 70.7%, we're going to reject the null, okay? So that cutoff point in the true distribution is also the cutoff point in the HA distribution. So let's look at when HA is true, right? So these clearly overlap. So now we're looking at this distribution here. And let's talk about what these decisions would be. If we are to the left of that number, we're going to reject, okay? So if we get any p-hat less than that, we're going to reject. If we get any p-hat above that, we're going to fail to reject. Okay, now, here's the thing. If we are over here on this lovely side and we reject, all of these are happy face decisions, right? We rejected the null and we were right? Because the HA is true. So this right here is the power of the test. This over here, if we don't reject, right, but the null, the alternate is true, this is our type 2, right? This is our type 2 error. If we get something in here and we don't reject, but the alternate was true, this is our type 2 error, okay? And then the power is everything over here. Now, again, you don't have to know how to get that. I just wanted you to see where it was coming from, all right? So let's look. If HA is true, what is the probability of an incorrect decision? So when we worked this out on the app, we saw that it was 24%. If the HA is true, what's the probability of a correct decision? That is 0.76%. So this is an incorrect decision. This would be a correct decision. And those have to add up to 100, okay? So here's what I will say in your red pen. The probability of type 2 plus the power has to equal 1. That's important. All right, let's interpret. This is a sentence frame that you're going to need to know, and we'll put it in our notes too. But here's the idea of the power. If, and it's always if the alternate is true, okay? And a very specific alternate is true. So we'll say this. In this particular scenario, if Miss Gallus is actually a 66% free throw shooter. There is a 0.76 probability that the significance test will find convincing evidence to reject the null. Okay? It's the probability that if the alternate's really true, that the test is going to get it right.